Hello, hello, and welcome to this video on regular expression in PostgreSQL. So we had read till this section, and we will continue reading it. So if you have not watched the previous four videos, you should go ahead and watch those because a lot of what is going to come was discussed in first two videos on regular expressions. So we'll try to finish as much as we can. There are roughly 10 pages left, so maybe two videos it will take to finish this. So without further ado, let's get started. Let me remove this. So we start. PostgreSQL's regular expressions are implemented using a software package written by Henry Spencer. Much of the description of regular expressions below is copied verbatim from his manual. Regular expressions, also written REs, as defined in POSIX 1003.2 come in two formats: extended REs or EREs, roughly those of egrep, and basic REs or BREs, roughly those of ed. PostgreSQL supports both forms and also implements some extensions that are not in the POSIX standard, but have become widely used due to their availability in programming languages such as Perl and PCL. REs using these non-POSIX extensions are called advanced REs or AREs in this documentation. AREs are almost an exact superset of EREs, but BREs have several notational incompatibilities as well as being much more limited. We first describe the ARE and ERE forms, noting features that apply only to AREs, and then describe how BREs differ. PostgreSQL always initially presumes that a regular expression follows the ARE rules. However, the more limited ERE or BRE rules can be chosen by appending an embedded option to the RE pattern as described in section 9.7.3.4. This can be useful for compatibility with applications that expect only the POSIX 1003.2 rules. A regular expression is defined as one or more branches separated by pipe. It matches anything that matches one of the branches. A branch is zero or more qualified atoms or constraints concatenated. It matches a match for the first, followed by a match for the second, etc. An empty branch matches the empty string. A quantified atom is an atom possibly followed by a single quantifier. Without a quantifier, it matches a match for the atom. With a quantifier, it can match some number of matches of the atom. An atom can be any of the possibilities shown in table 9.17. The possible quantifiers and their meanings are shown in table 9.18. The constraint matches an empty string but matches only when specific conditions are met. Constraint can be used when an atom could be used, except it cannot be followed by a quantifier. The simple constraints as shown in table 9.19, some more constraints are described later. So we have regular expression atoms here. So first atom is RE, where RE is any regular expression. Matches a match for RE with the match noted for possible reporting. Then we have question mark colon RE as above, but the match is not noted for reporting. Non-capturing set of parentheses, AREs only. Dot matches any single character. Then we have chars inside bracket, a bracket expression matching any of the chars. Then we have backslash k, where k is a non-alphanumeric character, matches that character taken as ordinary character. Example, backslash matches a backslash character. Backslash c, where c is alphanumeric, possibly followed by other characters, is in state. AREs only. In EREs and BREs, this matches c. Then we have brace, when followed by a character other than a digit, matches the left brace character. When followed by a digit, it is beginning of a bound. X means where X is single character with no other significance matches the character. An RE cannot end with the backslash. If you have standard conforming strings turned off, any backslashes you write in literal string constant will need to be doubled. Then we have quantifiers. Star means 0 or more, and plus means 1 or more. Question mark means 0 and 1. M inside basis, a sequence of exactly M matches of the atom. M comma, a sequence of M or more matches of the atom. M comma N, a sequence of M through N inclusive matches of atom. M cannot exceed N. Star question mark, non-greedy version of star. Star plus question mark, non-greedy version of plus question mark, non-greedy version of question. M followed by question mark, non-greedy version of M, and similarly M comma and M comma N. The forms using triple dot inside basis are known as bounds. The numbers M and N within a bound are unsigned decimal integers with permissible values from 0 to 255 inclusive. Non-greedy quantifiers available in AREs only match the same possibilities as their corresponding normal non-greedy or rather greedy counterparts, but prefer the smallest number rather than the largest number of methods. Then we note a quantifier cannot immediately follow another quantifier. Example star star is invalid. A quantifier cannot begin an expression or sub-expression or follow caret or pipe. Then we have constraints. Caret matches the beginning of string, dollar matches the end of string, question mark is equal to V. Positive look ahead matches at any point where a substring matching RE begins. Question mark, exclamation mark, V. Negative look ahead matches at any point where no substring matching RE begins. Question mark less than, positive look behind matches at any point where a substring matching RE ends. Question mark less than exclamation mark, negative look behind matches at any point where no substring matching RE ends. We have already seen all this. Look ahead and look behind constraints cannot contain back references, and all parentheses within them are considered non-capturing. Then we have bracket expressions. A bracket expression is a list of characters included in brackets. It normally matches any single character from the list. If the list begins with caret, it matches any single character not from the rest of the list. If two characters in the list are separated by minus, this is a shorthand for the full range of characters between those two inclusive in the collating sequence. For example, 0 to 9 will match any decimal digit. It is illegal for two ranges to share an endpoint. For example, A minus C minus C. Ranges are very collating sequence dependent, so portable programs should avoid relying on them. To include a little bracket in the list, make it the first character after caret, if that is used. To include a little minus, make it the first or last character, or the second endpoint of the range. To use little minus as the very end point of a range, enclose it in bracket dot and dot bracket to make it a collating element. With the exception of these characters, some combinations using bracket, see next paragraph, and states, AREs only, all other special characters lose their special significance within a bracket expression. In particular, backslash is not special when following EREs or BREs rule, though it is special in AREs. Within a bracket expression, a collating element, a character, a multiple character sequence that collates as if it were a single character, or a collating sequence named for other, include in bracket left dot, bracket dot, and dot right bracket, stands for the sequence of characters of that collating element. The sequence is treated as a single element of the bracket expressions list. This allows a bracket expression containing a multiple character collating element to match more than one character. Example, if the collating sequence includes a CH collating element, then the RE double left bracket dot ch dot double right bracket dot star matches the first 5 characters of CH. Now, one thing in all this discussion is you should carefully read this section, okay? Because how you can use a literal minus in the bracket notation, you should know, okay? So you should make it either the first or the last character, okay? So we have to be careful about it. PostgreSQL currently does not support multi-character collating elements. This information describes possible future behavior. Within a bracket expression, a collating element included in left bracket is equal to and is equal to right bracket is an equivalence class standing for the sequence of characters of collating elements equivalent to that one including itself. If there are no other equivalent collating elements, the treatment is as if the enclosing delimiters were left bracket dot and dot right bracket. For example, if O and caret are the members of an equivalence class, then double left bracket is equal to O is equal to double right bracket, and same with O replaced by caret and O caret are all synonymous. An equivalence class cannot be an endpoint of a range. Within a bracket expression, the name of character class should be included in left bracket colon and colon right bracket. Stands for the list of all characters belonging to that class. A character class cannot be used as an endpoint of a range. The POSIX standard defines these character class names alnum, which is letter and alpha, numeric digits alpha, that is letters, blank, space and tab, C and TRL, control characters, digit numeric characters, graph printable characters except space, lower is lowercase letters, print is printable characters including space, punctuation, space, any white space, upper class letters, X digit, hexadecimal digits. The behavior of these standard character classes is generally consistent across platforms for characters in the 7-bit SP set. So we had seen some of these in the second video on regular expression, the practical side of it, where we use these character classes. Okay, we had not used everything. I remember alnum we had used and digit we had used. Others were not discussed. So you can read and understand that. Whether a given non-ASCII character is considered to belong to one of these classes depends on the collection that is used for regular expression function or operator, or by default on characters ASCII type locale setting. The classification of non-ASCII characters can vary across platforms even in similarly named locales, but the C locale never considers any non-ASCII characters to belong to any of these classes. In addition to these standard character classes, PostgreSQL defines the word character class, which is the same as alnum plus the underscore character, and the ASCII character class, which contains exactly the 7-bit ASCII set. There are two special cases of bracket expression. The bracket expression, double left bracket colon less than colon, double right bracket, and same with left angle replaced by right angular bracket are constraints matching empty strings at the beginning and end of a word respectively. A word is defined as a sequence of word characters that is neither preceded nor followed by word characters. A word character is any character belonging to the word character class, that is any letter, digit, or underscore. This is an extension compatible but not specified by POSIX 1003.2 and should be used with caution in software intended to be portable to other systems. The constraint escapes described below are usually preferable. They are no more standard but are easier to type. Then we have regular expression escapes. Escapes are special sequences beginning with backslash followed by an alphanumeric character. Escapes come in several varieties: character entry, class shorthands, constraint escapes, and back references. A backslash followed by an alphanumeric character but not constituting a valid escape is illegal in AREs. In EREs, there are no escape outside a bracket expression. A backslash followed by an alphanumeric character merely stands for that character as an ordinary character, and inside a bracket expression, backslash is an ordinary character. The latter is one actual incompatibility between EREs and AREs. Character entry escapes exist to make it easier to specify non-printing and other inconvenient characters in AREs. They are shown in table 9.20. Class shorthand escapes provide shorthands for certain commonly used character classes. They are shown in table 9.21. A constraint escape is a constraint matching the empty string if specific conditions are met. Written as an script, they are shown in table 9.22. A back reference \n matches the same string matched by the previous parenthesized subexpression specified by the number n. For example, left parenthesis left bracket BC, right parenthesis right bracket \1 matches BB or BCC, but not BC or CB. The sub-expression must entirely precede the back reference in the array. Sub-expressions are numbered in order of their leading parentheses. Non-capturing parentheses do not define sub-expressions. The back references consider only the string characters matched by the reference sub-expression, not any constraints contained in it. For example, we are grouping caret \d \1 will match 22. So we have escape characters, character entry escape, \a is alert, \b is backspace, capital B is synonym for \c x, where is x is any character. The character whose lower order 5 bits are the same as those of x and whose other bits are all 0. \e is the character whose quality sequence name is escape, or following that, the character with octal value 33. F is form feed, \n is new line, \r is carriage return, \c is horizontal tab, \u wxyz, where wxyz is exactly 4 hexadecimal digits. The character whose hexadecimal value is 0x wxyz. Then we have capital U, this is 8 digit hexadecimal value. \v is vertical tab, \s x h h h, where HHH is sequence hexadecimal digits. The character whose hexadecimal value is 0xHHH. A single character, no matter how many hexadecimal digits are used. \0 is a character whose value is 0, that is null. \xy, where xy is exactly 2 octal digits and is not a back reference. The character whose octal value is 0xy. \xyz is where xyz is exactly 3 octal digits and is not a back reference. And the character whose octal value is 0xyz. Hexadecimal digits are 0 to 9, small a to f, small capital A to f. Octal digits are 0 to 7. Numeric character entry escapes specifying values outside the ASCII range 0 to 127 have meanings dependent on the database encoding. When the encoding is UTF-8, escape values are equivalent to Unicode code points. For example, \U1234 means the character capital U plus 1234. For other multi-byte encodings, character entry escapes usually just specify the concatenation of the bytes value for the character. If the escape value does not correspond to any legal character in the database encoding, no error will be raised, but it will never match any data. The character entry escapes are always taken as ordinary characters. For example, \135 in right bracket in ASCII, but \135 does not terminate a bracket expression. So we have \d, which matches a digit like this POSIX character class. \s is character class space. \w is character class word. \D is negation of digit. \capital S is negation of space. \W is negation of word. The class shorthand escapes also work within bracket expressions, although the definitions shown above are not quite syntactically valid in the constant. For example, A through C \D is equivalent to A-C digit colon. Regular expression constraint escape. Capital A matches only at the beginning of the string. \M matches only at the beginning of the word. Capital M matches only at the end of word. Small y and capital Y match the beginning or end of a word and matches only at a point where that is not beginning or end of a word. Capital Z matches only at the end of string. So in section 9.7.35, we will see how it is different from dollar. A word is defined as in the specification of double left bracket colon left angular bracket colon double right bracket, and same with right angular bracket above. Constraint escapes are illegal within bracket expressions. Then we have back references, backslash m, where m is non-zero zero digit, a back reference to the mth sub-expression. Backslash m and n, where m is a non-zero digit and nn is some more digits, and the decimal value m and n is not greater than the number of closing caption parentheses seen so far, is a back reference to the m and n sub-expression. There is an inherent ambiguity between octal character entry escapes and back references, which is resolved by following heuristics as hinted as above. A leading zero always indicates an octal escape. A single non-zero digit not followed by another digit is always taken as a back reference. A multi-digit sequence not starting with zero is taken as a back reference if it comes up with a suitable sub-expression. That is, the number is in the large legal range for back reference, or otherwise is taken as octal. So we will stop here, and in the next video we'll continue with regular expression metasyntax. So I know that I have not shown any example in this video because most of it we had already studied in first two videos. Some of it is new information, but mostly it is we have studied all the shorthand types and vector classes. Some of this is new. This table was new. Okay, so there are not many more examples which we can do here for what we have studied. So possibly later on, once I finish the theory, I will present some more complicated examples. So please wait for the theory to be over. So tomorrow we should be able to finish this. Let's see how much we have left. Regular expression metasyntax is here, okay, and then this. Yeah, tomorrow we should be able to finish this. Okay, let me see how much is there. Yeah, tomorrow we will finish this, and day after tomorrow we will see some complicated real-world examples of regular expression, and day after tomorrow we will finish this entire topic of regular expression. So I hope that you are enjoying this read-through and finding it useful towards extension of your knowledge. So thank you for your patience and your time and for watching the video. So we will meet tomorrow in the next video on regular expressions with PostgreSQL, and I'll take my leave here. You take care and have a nice day.